The final challenge for EV makers is getting their cars where their consumers are. BYD has a home base advantage in the China market, but Tesla has gained some with this factory in Shanghai. Built in 2019, this was the first of its kind for Tesla, and frankly, for any foreign automaker.
It got off the ground rather quickly, in large part because of the support from the local Chinese government. They wanted to help Tesla get going.
The local government in Shanghai granted Tesla a corporate income tax rate of 15% through 2023, a significantly lower rate than the standard 25%. The factory deal helped slash production costs for cars sold in the country, and Tesla was also able to get out of a joint venture agreement.
For years, if you were General Motors or you were Volkswagen and you wanted to build cars in China, you had to share the profit, you had to share the running of that joint venture, and Tesla didn't want to give up that kind of control.
Today, Tesla sells in over 30 countries, with manufacturing plants in the US, China, and Germany. BYD, having taken over China, is just beginning its global push. Its passenger EVs are currently for sale in China and a handful of other countries. The US is not yet one of those.
In part because of the US-China tensions right now, it's hard for any Chinese car company to say they're making a foray into the US market right now. It's also hard for car companies to just think about expanding into market by exporting there purely without manufacturing locally.
The fight for the global EV market has a ways to go. In China, the market needs to mature on its own without government subsidies, while the US needs to dramatically improve its supply chain in the country and up its EV adoption rate. As for the companies themselves, BYD has yet to fully articulate its plans to enter the US passenger EV market. While China's biggest EV maker faces pressure to expand, BYD said customer satisfaction is its main goal and top priority.
I've been writing about the automotive industry for almost 20 years, and there's always been this kind of belief that the Chinese car companies were on the verge of coming to the States. We haven't really seen that yet. Creating the infrastructure to sell the vehicles is a challenge.
Tesla did not respond to a request for comment, but the company also faces its own obstacles ahead.
They need to show growth to the investment community. And we have seen investors really be forgiving at the idea of chasing sales volume at the potential cost of profitability.
If electric vehicles are truly the future of the car, owning this market could be paramount to a country's economy. In order for that to be a reality for Tesla, EV batteries will need to be made in America.
This is the A100 chip from the US giant Nvidia. It's one of the world's most advanced computing processors, which helps develop artificial intelligence that's used in everything from self-driving cars to making drugs and even building weapons. And this is one of its newest competitors, made by a Chinese startup. Industry analysts who track the speed of chips say this model is even faster than the A100 based on initial tests.
It produced performances that were significantly more competitive than previous AI chips coming from China.
Here's how the design and capabilities of these two chips compare as the race for dominance in tech is ramping up. The US has been a pioneer in the semiconductor industry for over 70 years.
The US essentially gave birth to the semiconductor industry and the semiconductor economy.
Wayne Lam is the director of research with tech consulting firm CCS Insight. For over a decade, he has been researching American chip technology.
The US was an ideal place because it started much of the research and core sciences.
In the late 1940s, American scientists invented the first transistor, the fundamental technology behind all chips. Early versions of chips fit inside computers that helped calculate projectiles and get NASA space programs off the ground. But the industry really took off in the 1960s with the rising demand for consumer goods like televisions and corporate computers. That boom also drove chip companies to spring up across Asia, with Taiwan Semiconductor Manufacturing Company now leading the industry, making more than 90% of the world's most advanced chips. Still today, the US is home to some of the world's leading chip designers, and they help power everything from our smartphones to laptops and data centers. China, on the other hand, has long been trailing the US, and for several decades it has actually relied on American companies, as well as chip makers in Taiwan and Japan. In 2021, China imported more than $430 billion worth of chips, exceeding that of oil. So Chinese President Xi Jinping has made it a top priority to change that.
It's absolutely important on a strategic basis.
Gregory Allen is a senior fellow at the Center for Strategic and International Studies, a think tank based in Washington, D.C. He's been following Beijing's AI and semiconductor policies for about 7 years.
What they essentially wanted in the semiconductor industry was for more of the chips that were used in China to be made in China.
So to become more self-reliant, Beijing promised to provide about $180 billion in state funding to support its domestic chip industry. The goal is to design chips that can be as fast as the American ones, like this AI chip from Nvidia. And this model released in August by Biren is the latest demonstration of China's progress. Like its American rival, the Biren chip is also a graphics processing unit, or GPU, and both are designed to help computers perform complex tasks faster. So what makes a chip powerful? To improve their performance, both companies are using the same type of transistor. It's the fundamental unit that basically controls the flow of electronic signals, and that allows the chips to store data or run calculations. But unlike the first transistor invented in the 1940s, the ones today are so small that they are measured in nanometers, which is a fraction of the width of a human hair. 7-nanometer transistors are now the base for both Nvidia and Biren's high-end chips.
So the smaller the transistor, the more transistors you can pack into the same surface area of a silicon.
The American chip is designed with more than 54 billion transistors over a plate of about 800 millimeters square, whereas the BR100 is slightly bigger, with about 77 billion transistors packed into about 1,000 square millimeters. While there are many factors that determine a chip's performance, industry experts say having a higher number of transistors can help increase the Chinese processor's speed. Biren says its chip can perform more than 1,000 trillion operations per second at its peak. Write it out, that's 15 zeros. That's about 3 times the stated speed of Nvidia's A100. But whether Biren will be able to dominate the market will require more than designing chips. Producing them is also a huge challenge, because it requires precise manufacturing to squeeze these billions of transistors onto a tiny surface.
Semiconductor manufacturing is perhaps the most technologically complicated thing that the human species does.
One of the most complex processes is called lithography, which blasts UV light through photomasks and prints patterns on silicon wafers, adding layers to form the transistors.
You need to be precise. Some of the layers in these semiconductor transistors are only 1 atom thick.
So Nvidia and Biren both look to another company for manufacturing. You may have guessed that's the Taiwan Semiconductor Manufacturing Company, the world's largest contract chip producer.